Good morning everybody. Welcome to CEI. This is Dr. Sekhar, chemistry teacher. Today I will teach acid base salt. We continued because I have already started. Now preparation of bases. Before preparation of bases, few things are left that I will teach today. Last day I have discussed about the definition of bases. How will I define? There are three conceptual definitions are there. After that, I have given the examples of strong acid and strong bases and the differences. The next topic will be acidity of a base. Acidity of a base is the next topic. What is that? Acidity of a base is the number of replaceable hydroxyl ions present in a base. Number of replaceable hydroxyl ions. As we know, in case of acid, it was replaceable H plus ion, and here it is replaceable OH ion. So there are three types of there. One is monoacidic base, diacidic base, triacidic base. Mainly there are three kinds of bases we find acidity. First is monoacidic base. Monoacidic base example. Monoacidic base NaOH, KOH, NH4OH, etc. because they have one replaceable hydroxyl ion. Diacidic base example calcium hydroxide, magnesium hydroxide, barium hydroxide, etc. Why? Because they produce two hydroxyl group. This is one triacidic base like aluminum hydroxide, ferric hydroxide, etc. because they produce Al3 plus 3 hydroxyl groups. So let me conclude. Acidity of a base. Acidity of a base means replaceable hydroxyl ion present in a base. Monoacidic base, they have one replaceable hydroxyl group, NaOH, KOH, NH4OH. Diacidic base, there are two replaceable hydroxyl ion, calcium hydroxide, magnesium hydroxide, barium hydroxide. Triacidic base, three replaceable hydroxyl ion, aluminum hydroxide, ferric hydroxide. Now I am showing here one OH, mono, di, two OH, tri, three OH. So acidity of a base is the hydroxyl ion which can be replaced from a base. Okay. Second is difference between base and alkali. Now what is bases? Metal oxide and hydroxides are called bases. Metal oxide and hydroxide. Metal oxide means sodium oxide, calcium oxide, magnesium oxide, iron oxide, ferric hydroxide, oxide, hydroxide, sodium hydroxide, potassium hydroxide, calcium hydroxide, magnesium hydroxide, barium hydroxide. They all are bases. So metal oxide and hydroxides are called bases. What about alkalis? Alkalis are only soluble bases. Alkalis are only soluble bases. They are called alkalis. So that means soluble bases are called alkalis. Example: NaOH, KOH, COH whole twice, BaOH whole twice. That means sodium hydroxide, potassium hydroxide, calcium hydroxide, barium hydroxide. They are alkalis because they are soluble in water. So in case of calcium hydroxide, if you take calcium hydroxide powder, then and add water, we get two types of mixture, two types of things we will find. One is sedimentation, and above sedimentation we will see some transparent solution. This transparent solution is lime water, which is alkali, but the sediment portion that is called slaked lime, that is base. So calcium hydroxide, there are two types. One is alkali, another is base. Soluble part we will call alkali lime water. Insoluble part calcium hydroxide is called slaked lime. So in case of calcium hydroxide, we find both the base and alkali. So let me conclude. All metal oxides and hydroxides are bases. Only soluble hydroxides or only soluble oxides and hydroxides are called alkalis because they are soluble in water. Now next is, then we can conclude that all alkalis are bases, but all bases are not alkalis. So I repeat, all bases are not alkalis, but all alkalis are bases. Okay. So this is the difference between bases and alkalis. Next part, uses of bases. Uses of bases, very important or very familiar to everybody. As an antacid, as an antacid, we use magnesium hydroxide. Very common and popular popular medicine, that is called antacid, because almost all of you are used, because for indigestion it is mainly used. Magnesium hydroxide is called antacid. Fire extinguisher, we use aluminum hydroxide. Bleaching powder manufacture, we use calcium hydroxide. For soap industry, we use sodium hydroxide and potassium hydroxide. Sodium hydroxide for washing soap and potassium hydroxide for toilet soap. So there are many uses. Among them, for sometimes some removal of stain, grease stain from clothes, we can use ammonium hydroxide. So there are bases are there which are very useful in our daily life. I repeat that for soap industry, NOHQH, for our medicine, that is magnesium hydroxide, for bleaching powder, calcium hydroxide, for fire extinguisher, we use aluminum hydroxide, and so on. So uses of bases we can discuss. Next is preparation of bases. There are many methods. Among them, 3 or 4 methods we will discuss. That is, first, by the oxidation of metals. First is by the oxidation preparation of bases. Number 1, by the oxidation. By the oxidation. By the oxidation means when metal combines with oxygen, they form metal oxides. So metal oxides are bases, you know. Example, I am giving few examples. Na plus O2, Na2O, 4Na, 2NO2, 4K plus O2, 2K2O, or CaO, 2C plus O2, 2CaO, or Mg plus O2, MgO, 2Al plus O2, Al2O3, etc. So by the oxidation of metals, by the oxidation means when they combine with oxygen, the respective metal oxides are formed. They are called bases. So this is the first method. How will I prepare bases? Second, I will discuss about this one. By the addition of water to alkali metal oxide, to alkali metal and alkaline earth metal oxides. After that, I will discuss this one. Now, by the addition of water to alkali metals and alkaline earth metals. Alkali metals, you know, lithium, sodium, potassium, rubidium, cesium, francium. But cesium, francium we will not discuss because they are the radioactive element. So lithium oxide, sodium oxide, potassium oxide, they all react with water to form alkalis. like lithium hydroxide by reacting with water, sodium oxide reacting with water forms sodium hydroxide, potassium oxide forms potassium hydroxide, and so on. And alkaline earth, we know alkaline earth contains beryllium, magnesium, strontium, barium, and radium. So they are also alkaline earth. They are also by dissolving water from the respective alkalis. Now let me write few examples. Na2O plus water twice NaOH, K2O plus H2O gives twice KOH, Li2O plus water to give twice LiOH, CaO plus H2O, CaOH all twice. Now by the addition of water, two alkali metals oxide, sodium oxide, potassium oxide, lithium oxide, and alkaline earth, calcium oxide. So they all dissolve in water to form the respective hydroxide or alkali. So this is the second method. First method, by the oxidation, by the combination of direct union with oxygen to the respective oxides called bases. And when bases like metal oxides, mainly alkali and alkaline earth metal oxides, they form alkalis by reacting with water. So number C we have discussed. And number B, by heating salts like carbonates, nitrates, sulfides, etc. By heating we will get, suppose by heating carbonates we get respective oxides and carbon dioxide. By heating nitrates we get respective oxides, nitrogen dioxide and oxygen. And by heating sulfides we will get the respective metal oxides and sulfur dioxide. And we will get some few examples, or we will write few examples of the salts like carbonates, nitrates, and sulfides. Now first is by heating carbonate. By heating carbonate. Now carbonates, suppose calcium carbonate, we get calcium oxide plus carbon dioxide. By heating zinc carbonate, we get zinc oxide plus carbon dioxide. Now here is important, that is zinc is white powder. Zinc is white powder. And zinc oxide, you know, when heated it is yellow when hot, and white when cold. Now calcium carbonate heated, we get calcium oxide and carbon dioxide. Calcium carbonate white powder, calcium oxide also white powder. No change in color, but only the oxides are formed. Base. Zinc carbonate is a white powder. On heating, we will get zinc oxide and carbon dioxide. Zinc oxide is a base. But the important characteristics is that zinc carbonate, it is white powder. On heating, when zinc oxide will be formed or will be produced, it turns to yellow when it is hot. But when it is cool, it becomes again white. Yellow when hot on heating and white when cold. Similar, another example, lead nitrate. It is lead carbonate. On heated, lead oxide plus carbon dioxide. Now here, lead carbonate is white powder. Lead carbonate is white powder, and it is orange when hot, yellow when cold. Yellow when cold. Now in this case we find lead carbonate like zinc carbonate is white powder, because carbonates are usually white powder, usually exist in powder amorphous state. So lead carbonate is a white powder. They form lead oxide which is a base, and carbon dioxide. Now, characteristics of lead oxide is it is orange when hot and yellow when cold. Next is nickel carbonate. NiO plus CO2. It is green powder. Last class I have told green powder, and it is black powder. Now nickel carbonate, which is green powder, and nickel oxide is black powder. Now I have given this type of examples. There are more examples. One more I will give you. That is copper carbonate. Last example regarding carbonates. Copper carbonate, CuCO3, CuO plus CO2. CO is green powder, CO is green powder, and this is black powder. So let me conclude. Let me conclude that calcium carbonate, calcium oxide, carbon dioxide, zinc carbonate, zinc oxide, carbon dioxide. Important point: zinc oxide characteristics yellow when hot, white when cold. Lead carbonate, heating lead oxide, carbon dioxide base, lead oxide base. Lead oxide is the orange when hot and yellow when cold. Nickel carbonate in both the conditions, that is cold and hot in both the conditions, is a black powder. And finally, copper carbonate, it is a green powder. When it is heated, it forms black powder of copper oxide. So this is the heating of carbonates. Heating of carbonates discussed. Now heating of nitrates. By heating nitrates, by heating nitrates, suppose if I take calcium nitrate, we get calcium oxide plus 4NO2 plus O2. Now zinc nitrate, if we zinc oxide plus NO2 plus O2. Now lead nitrate, on heating we get twice lead oxide (4NO2) plus O2, and copper nitrate, we get CuO, 4NO2 plus O2. So let me discuss. Now when calcium nitrate is heated, we get calcium oxide, nitrogen dioxide, and oxygen. You know nitrogen dioxide is a brown fumes. Now calcium nitrate on heating, we get calcium oxide, nitrogen dioxide, brown fumes, and oxygen. Now by heating zinc nitrate, we get the zinc oxide, nitrogen dioxide, and oxygen. Characteristics is zinc nitrate is a crystal, white crystal. This is white crystal. All are white crystals. They all are white crystal. They all are white crystals. Calcium nitrate white crystal, zinc nitrate white crystals, lead nitrate white crystals. Those crystals on heating, they produce the respective oxides, nitrogen dioxide, and oxygen. Now in case of zinc oxide, as already I have said, that yellow when hot, white when cold. In case of zinc oxide, and in case of Lead oxide is yellow, orange when hot, yellow when cold, with the evolution of brown cubes of nitrogen dioxide, as well as oxygen gas evolved in each case. But in case of copper nitrate, it is a blue crystal. It is a not green powder. It is a blue crystal. It is a blue crystal. Blue crystals, when heated, it forms cupric oxide, black powder, nitrogen dioxide, and oxygen. So let me conclude. By heating carbonates and nitrates, they produce the respective oxides, which are known as bases. With the evolution of, in case of carbon dioxide, carbonate, carbon dioxide. In case of nitrate, it will be nitrogen dioxide with oxygen gas. And in case of sulfides, last one, that is sulfide. When sulfides are heated, they form respective oxides and sulfur dioxide. Like calcium sulfide, we get calcium oxide and sulfur dioxide. Zinc sulfide, we get zinc oxide and sulfur dioxide. Lead sulfide, we get the lead oxide and sulfur dioxide. Thank you. Thank you very much. If you like this video, you like, share and subscribe. Thank you.